Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to solve linear inequalities. Now, I'm going to assume you're comfortable solving linear equations before we get started, as linear inequalities are solved very similarly to linear equations, with one important difference, which I'll come to in a moment. Now, when we're solving a linear inequality, we can do the same sorts of things we do when solving linear equations. I can add a number to both sides of the equation. I can subtract numbers from both sides of the equation. And I can multiply or divide both sides of the equation by any non-zero number. But when I multiply or divide both sides of my inequality by a negative number, what's going to happen is the direction of the inequality will change. So suppose I have this inequality here, x is less than y, and I multiply both sides of this inequality by some negative number, let's just say -2. Then what happens is I get on the left side, I get -2x. On the right side, I get -2y, but the inequality must change direction. So again, when you multiply or divide both sides of the inequality by a negative number, you must change the direction of the inequality. Other than that, it's almost identical to solving linear equations, aside from how we have to write the solution set. Let's begin with an example. Find and graph the solution set of -4x minus 2 is greater than 14. So our strategy here is very similar to that solving a linear equation. I want to get x on one side of the inequality and a number on the other side. So to do that, we start by adding 2 to both sides. So that gives us -4x is greater than 16. And I want the coefficient of x to be 1. So we divide by the coefficient of x on both sides, which is -4. Now, since I've divided by a negative number on both sides, I get x. Instead of getting greater than, it's going to be x is less than. It must change the direction since I divided both sides by a negative number. So I get x is less than -4. On the number line, if I want to graph this, here's -4. Less than -4 means to the left. So we just graph to the left of -4. I'll use an open circle here to indicate that we're not including -4 in the solution set. If I want to write this as an interval, right, the left endpoint would be -infinity. The right endpoint would be -4, which is not included. In set builder notation, we have x such that x is less than -4. And set builder notation is the easiest. Once you've found the solution, when you're done, you just write x such that, and then you just put whatever the end inequality was. And that's it. Here we have a more complicated example, but again, the strategy is the same as when we were solving linear equations. I just want to simplify both sides of this inequality, and then I want to try to get x on one side and a number on the other side. So first, we start by distributing on the left-hand side. So this will give us -15 plus 12x is greater than, it's going to be 2x. It's going to be 2 times -4 is -8, plus 3 is -5. Okay, and now I'm going to add 15 to both sides of the equation. Okay, that gives me 12x is larger than or equal to 2x plus 10. And I can subtract 2x from both sides of the equation. That will get all my x terms to the other side. And that leaves me with 10x is greater than or equal to 10. And now the last step is to divide both sides by the coefficient of x, which is 10. So we get, on the left-hand side, we get x is greater than 1. And again, now the direction does not change because we're dividing both sides by a positive number. To graph this, so x is greater than or equal to 1. So on my number line, here's 1. Okay, greater than or equal to 1 would be to the right of 1. So we put a closed circle since we include the point 1 in our solution set, and we graph to the right. Okay, if I want to write this in interval notation, it would be 1 to infinity. Right, the left endpoint is 1, the right endpoint is infinity. We use a bracket here because we're including 1. And as I said before, in set builder notation, that's the simplest. You just write your curly brace, you write x, and you write the such that line. And then you just include the last inequality you had. So x is greater than or equal to 1. Another small difference between linear inequalities is that you can run into interesting situations that don't occur with linear equations. This example will show you what I mean. So we start by simplifying both sides. We have 2x plus 1 on the left-hand side. On the right-hand side, we distribute that 2. We get 2x plus 3. So 2 times 3 is 6. Minus 4 would be positive 2. And now I notice here, if I subtract 2x from both sides, there's no longer any variable here. And I get 1 is less than or equal to 2. So here's the thing. No matter what the value of x is, that inequality is always true. 1 is less than or equal to 2. And so that means that for any value of x, this inequality is always true. So the solution set, so if this was an equation and you got 1 equals 2, that cannot be true. And so you might write no solution. But since 1 is always less than or equal to 2, what that means is no matter what the choice of x is, we're good. So that means the solution set is actually all real numbers. So you can write that, if it says graph it, but I mean, if you're graphing it, you can just write, like this. Okay, for an interval notation, you can write negative infinity to positive infinity. And for set builder notation, a little weird to write this in set builder notation, you can just write x is between negative infinity and positive infinity. A little strange to write like that, but what are you going to do? Here's our final example. So again, we want to find and graph the solution set of this particular inequality. So we start by, again, simplifying both sides. On the left-hand side, we get 3x. When we distribute, we'll get 3 times negative 2 is negative 6, plus 1 would be negative 5. That is greater than, we distribute that negative sign, we get negative x. We're going to get negative 3, and then plus 4x. So if we simplify this, we'll get 3x minus 5 is greater than 3x minus 3. And you'll notice we have the same quantity of x on both sides. So if I subtract 3x from both sides, then they cancel out on both sides, and we get negative 5 is greater than negative 3. It's important to note, though, that that is never true, right? Negative 5 is not greater than negative 3. So no matter what the value of x is, this inequality will never be true. And so this is when we would say no solution. So the way we write no solution when we're talking about a set is that there is no x that solves this inequality. So that is what we call the empty set. So usually you just draw a circle with a line through it to symbolize the empty set, which is the set that has no elements in it. And that's it for solving linear inequalities. Now, it's very similar to solving linear equations, okay, except for the few small differences we've mentioned in this video. If you practice this, you'll have no problem picking those out, and you'll master this in no time. All right, until next time, have fun.